Okay, so those were the book problems that I wanted to go over. And now what I want to do is you have gotten, I want to go over this normal distribution problems from day 2. You have gotten that. I don't think that you may not have done this yet. But here is what that looks like. And I want to kind of go over some of the notation that's on here for this problem, or for these. Okay, so if we take a look at this paper here, it says find the area under the curve for these problems 1 to 10. Okay, so notice these are given to you in z-scores. Okay, so you already have your z-scores. Now, if you have z-scores, what are you going to do in your calculator to get out the area? Because that's what we're trying to get is our area. Well, that's when you do your norm CDF. Because your norm CDF is going to give you your cumulative area between your two z-scores, which have to be listed from least to greatest. So in this case, the least is here up to the greatest of 0. And so that's how you would calculate, and it would give you that area. And you could write that as a decimal answer or as a percentage answer. Either one is perfectly acceptably fine on the AP exam. Okay. But how would we handle something if it says we want it to the left of this area? So here's our z-score of 2.56, and we want all of this area to the left. Then, in essence, we need a z-score of the top one is 2.56, but what's this z-score down here? Well, you have to remember that on a regular normal curve, you know, here's 1 standard deviation, here's 2 standard deviations, here's 3 standard deviations, -1, -2, -3. How much information is contained within 3 standard deviations? 99.7% of information is contained within 3 standard deviations from the mean. So if I go out here to a big old huge amount of negative standard deviations, then that's essentially like going down to negative infinity. A student in my first period class actually came up with the fact that 7.3 is as far as you need to go, statistically speaking. But we're going to put negative 99 standard deviations into our norm CDF. Okay, so then in order for me to calculate the area below 2.56, I'm doing my norm CDF from negative 99 up to 2.56. Okay. And likewise, this one on the right, if I want to go to the right, then I'm going to be going out to positive infinity. So 1.12, so norm CDF from 1.12 out to positive infinity. And so we'll say 99 standard deviations. That's about as close to infinity as I think you could get in standard deviations. Okay, so there's that part. Now, let's take a look at the next page. This has curves with some areas already. And I want you to find the missing z-score. So let's find this missing z-score right here. And this point 4826 is this area that is shaded. So how do I find z-scores? In my calculator or on the table? How much area do I have to have? I have to have all of the area below that value to get my z-score. Okay, so, but all I know is this part. Well, what's this part right here below the mean? Below the mean would be how much percent? That'd be 50%. So to get all the way up here to this z value, I add those together for a total area of 0.9826. So therefore, I want to find the z-score of an area at 0.9826. And that would give me that z value all the way up to here. So that's kind of the key to these here, is you have to keep in mind that mean gives you an area of 50% or half. All right, let's just kind of look at number 13, and then that'll be the last one we'll do here. So this area is that, and I want to know what this z-score is right here. Okay. So how could you do that? So think about that for a second. What is below the mean? 50%. So if I did 0.50 and I took off this part here, which is 0.850, then that would leave me with this part that is left. You have to think geometry, an area minus another area. And that's 0.015. So if that's the area, find the z-score of that area, and that would give you this z-score right here. That gives you an area of 0.015 below. Okay, so that's all I'm going to say on that part. Now let's go to the last page. Which reminds me, actually, 9 and 10 on that first page, look at how this is written. This we've not seen written this way before. That's saying, what is the percent of observations, or the probability that you will have a z-score in between 0.12 and 1.09? So if we were to look at a picture, I want to know, here's 0.12, and here's 1.09. So I'm looking for the probability that you have that amount area there in between 0.12 and 1.09. Okay, so it's notation-wise written a little bit different, but we know what that means. Okay, now look at number 17. You do not have a standard normal curve with a mean of 0 and a standard deviation of 1. You actually have other mean and standard deviation values. So how can I find the area in between two other values? Notice this is an x, not a z-score. So what do I have to do with these numbers first to be able to then calculate the area? I need to translate those into z-scores. Okay, so do you remember that formula that you had to have memorized of how to translate into z-scores? It's your data minus the mean divided by standard deviation, which in this case would be -3 minus 2 divided by 5. So this z-score is -1. And 6 as a z-score is 0.8. So this is like saying the percent of observations of a z-score from -1 to 0.8. And now then you can do your norm CDF from -1 to 0.8. Okay. And so that's pretty much how you can do all of those. That's it. Okay, so that, and look, notice that the answers are at the bottom. I think this number 20 is a wrong answer. I think it's 0.0400, but I think everything else, I haven't had anybody else come and show me the wrong answer on that. Okay, so you can check yourself, make sure that you're getting all those areas correctly and that you are translating between areas and z-scores very efficiently and you know what you're talking about. Okay, now I want you to take this mid-chapter quiz A. It's a version A, but I want you to do it as a warm-up. So So I want you to pause this recording and spend some time going through that. It's pretty in-depth and very much application, and so it's a really good warm-up to do to prepare for the quiz and to make sure you know what's going on in this chapter. So I want you to pause right now, spend some time doing that, and then we're going to go over the answers. Okay, before I go on to those answers, I had put a drawing up here. I didn't have a very good drawing, I think, for the first part of this video. And I wanted to show you that if you were just shifting this item by adding and subtracting values, that the mean, median, and mode, those just add and subtract. However, if you are rescaling by multiplying or dividing, that's like a dilation. So the standard deviation as well as the position change. See, so it's gotten more spread out in addition to just changing the position. Okay, so I thought that would just be a little bit better feature to show you that than that one I was trying to draw earlier. Okay. But back to the warm-up. Let's go ahead and do this. These first ones are pretty simple. I'll just give you the answers for the warm-up. Number 1 was 1250.45. Number 2, the standard deviation only was affected by multiplication, so you only multiplied it by 73. You did not also add 35. Number 3, the median is affected by both addition and multiplication. So that's that. Number 4, IQR only affected by was only affected by the multiplication factor. Okay. So B. Question B, or 1AB, 1B, says it's 28 credit hours, an outlier. Okay, so there's 2 different ways you can think about an outlier. You can either go by the IQR. So some of you may have done this. Remember, the IQR is your Q3 minus your Q1, so that was 4. And to find out if you have outliers, add it to your Q3. So do 1.5 times your IQR and add that to your Q3. And if you do that, then you get 25 credits. And so if you have 25 credits, so that means that on your box plot, your outlier fence is out here at 25 credits. Well, since 28 credits is outside of that, then 28 credits would be considered an outlier. Okay, so that's one way to do that. All right, and that would be perfectly acceptable in the AP process. That's one way that we would define an outlier. The other way, and since we're kind of be talking about normal curves, the other way to define an outlier is if it's falling outside of these 3 standard deviations. So if it's outside of 3 standard deviations, then it would be an outlier. So what I did on that was I took, the way I did it was I translated it into money. So $35 plus $73 for 28 credit hours means that you have to pay $2,079 for 28 credit hours. So then I did my z-score to find out how many standard deviations that value is above the mean. And I do my data, which is this price here, minus the mean price. Well, where do I find the mean price? That was up there, up above, the very first problem. The mean price is $12.50.49. divide it by the standard deviation, which was the second problem we did, 21608, and I find that that equals 3.8. So that's 3.8 standard deviations. That means you're out here. So you are outside of 3 standard deviations. Therefore, I would consider that an outlier. Okay, number 2, no problems on that one. Just make sure that you know that the mean is 100, and when you go over 1 standard deviation, you're adding 15 because the standard deviation was 15. So this is at 115, and that's one standard deviation. Now this would not be the sigma because this is actual data, so this would be a little s. And here at 2 standard deviations, I add another 15, and that's a value of 130. Okay, and then out here at 3 standard deviations, I would add another 15, and that's 145. And so on, and then you subtract 15 in each of these directions. All right. So let's go on to the back. Number 3. You want to see how the Dalmatians and the boxers are relating as compared to average. So what you want to do is you want to find your z-score of both of these. Your z-score of the Dalmatians is 45 minus the mean divided by the standard deviation, and that's negative 1.52. So what is this saying? That's saying that that Dalmatian is 1.52 standard deviations below average, whereas this boxer has a z-score. I'm going to take the boxer minus the mean of the boxer divided by the standard deviation of the boxer of negative 3.24. So what is that one saying? It's saying that the boxer is 3.24 standard deviations below. So not only is that more, it's probably pretty much considered an outlier because it's over 3 standard deviations away from the mean. So that's huge. So to answer the question, which dog is more underweight? Well, obviously, the boxer is more underweight because the boxer is 3.24 standard deviations below average, and the Dalmatian was only 1.52 standard deviations below average. Okay. Now, number 4 is totally the best one. It's intense. It is so great because what it does is it's really kind of making you put IQR and standard deviation all together at once. It's just really a culmination of many, many things. Okay. First of all, when you read this problem, to me the first 3 lines are just blah, blah, blah. They really are just kind of extra information. And what's important is that you know that we are dealing with a normal model with a mean of 98.7 and a standard deviation of 0.7. Okay, so we'll go from there now. So A, no problem. We want to find the percent of people, so that's going to be the area that are below 97 degrees. So drawing a picture, here's 98.7, here's 97. How many people are below that point? So how do I get that? I find the area below this value, and so I need that z-score. So I need to find the z-score by saying 97 minus 98.7 divided by 0.7. That gives me a z-score there of negative 2.43. So I want the area from negative 2.43 z's down. How do I get area on my calculator? Cumulative areas, norm CDF, from least to greatest, negative infinity. So how many z's do I consider negative infinity? Negative 99 up to this point, negative 2.43. So I'm going to go put that into my calculator, and I'm going to see what I get. And the answer key that I have is not entirely perfect, so let me go ahead and let's put that in the calculator and see. Okay, so 0.0075, what does that mean? You know, you could say that number or you could say 0.75%. So that's not very many of people that would have hypothermia. Okay. B, 4B. Find the interquartile range. Okay, so what do you know about interquartile range? Well, interquartile range would be 25% and at 75%. So we got to go find out what those z-scores are. Let's do that real quick. If I want to find a z-score and I know an area, then I'm going to put the area into inverse norm. Okay, so 0.6745, and the other one I guess would be the inverse of it. So that's a z of 0.6745, negative on this side, positive on this side. Okay, so then let's see, if we want to find what this range is, give these actual values in degrees. So how many degrees is that? How many degrees is that? Well, don't I know that this is 98.7? Okay, and so the way I think about this is to get this, that's 98.7 plus how many standard deviations? 0.674 standard deviations, which how much is the standard deviation? From the problem, that's given. 0.7, that's given to us. So 98.7 standard deviations above the mean. And so that would make this .17. Okay. Whereas over here, I have 98.7 minus 0.6745 standard deviations. And so what is that temperature? So I got that temperature is 98.23. Okay? So what's the interquartile range? So the IQR would be the distance from Q3 to Q1. So subtract those two. And, you know, you're going to have a rounding thing here depending on where you rounded, if you didn't round or if you did. But somewhere around the 0.94. I had some people having 0.94, some people having 0.945 because they then kept all their decimals. Yeah, you want to keep as many decimals as possible into there. So somewhere along those lines, I'd probably be looking in this area knowing that past that is a rounding issue. Okay, and so now the very last one, 4C, is this. So they decide, this company makes they say more accurate thermometer. There's less variance. They say that their IQR is now 0.5. as opposed to the 0.945 that we just calculated. Okay, so that's a lot more accurate, I would say. So let's think about what that's saying. Our mean is 98.7, and so then the question is, what's the standard deviation? Okay. So if I have an IQR of 0.5, there's my 75% and my 25% representing my IQR. If I have a distance here of 0.5, from here to here is 0.5. How much goes in each direction? Plus 0.25, that would give me the degrees here. And so that would be my 98.95 degrees. And if I also had a 20.25 here, that would give me my other degrees on that side, which, whatever that is. Actually not important. I mean, I can just go with one value, one side, and I'll be fine. Okay, so what is this z-score right here? Z-score at 75% we already calculated was 0.6745. Okay, so look, I have an actual data value. I have a z-score. I have my mean. And the thing that's missing is my standard deviation. So do you remember from the book problems in the first video, my z-score is my data minus my mean divided by my standard deviation. So my z-score is my data, take away my mean, divided by my standard deviation. Now just solve for S. And if you do that, I got that the standard deviation is 0.37. Okay, so that's the warm-up. And so let me summarize what I want you to do for homework. Because we've gone through quite a bit of things. Okay, so what I want you to do for homework, and you can work on this the rest of the class, is this. If you have not finished reading this chapter, you have to do that. This normal stuff has to be just really easy. This book page is optional, okay? I definitely want you to do this normal distribution page day 2. That's a worksheet. I definitely want you to do this worksheet. And this Chapter 6 review is also a worksheet. I want you to do that worksheet. Those are the two things that I definitely will expect that you have gone through by next class. Finally, since we're doing a quiz next class, if you struggled with this warm-up, you want to study your warm-up, because we're going to have our mid-chapter quiz next class, which is actually at the end of the year, or end of the chapter. And then we'll have a review day on Wednesday, and our test will be next Friday. Okay? All right. So there you go.